Okay, here we go with a conceptual-based question, which I've seen many times before in different guises, all about phase difference and between, in this case, displacement and acceleration for SHM. Have a think. When you're ready to see the answer, press play. Okay. As I say, this has been in many papers. I've seen it many times. I'm sure I'll post many similar videos to this one. And think the tricky bit for students here is that idea of phase difference, because we often talk about phase difference between, for example, traveling waves, if we're talking about interference or young slit or double slit experiment, etc. Okay, let's just have a look here. What we should be aware of is that when SHM happens, okay, we have graphs like this. So, for example, we might have a sine graph for our displacement, cos for our velocity, and then a minus sine graph for our acceleration. Now, we're focusing here on displacement acceleration, so we want to look at that blue and that red line there. Now, what I'm going to do is I'm going to put a little line on here, and that really is marking the position of a peak in the displacement. Okay. And then let's try and mark the position of the peak in the acceleration. What you should notice there is that distance between those peaks, if you like, is half a wave, or in other words, half a wavelength. Now, we know that one whole wave, if these guys were out by one whole wave, then they would have a phase difference of 2 pi. But that's not the case here. We're out by a distance of lambda over 2, so therefore, what you've got there is a phase difference of pi. When we talk about a phase difference of pi, what that means is one is at its positive maximum, and at the same time, the other one is at its negative minimum, and then vice versa. And you can see that that is the case in this graph. When x is really big, or really positive, I should say, a is really negative. When x is really negative, a is really positive. They don't have the same amplitudes, of course, because we're related by our a equal to minus omega squared x. However, that is their phase relationship, pi radians.